Right, here we are on page 2 of the review of quadratics. So we're starting out with a factored form. Do you see those parentheses up here? This is already in factored form. When given an equation in factored form, let's see how we would get the following things. So to get the y-intercept, the definition is when x is 0. So we're going to go plug in 0 everywhere that there's an x. So 0 minus 6, 0 plus 4, is going to turn out to negative 6 times 4, or negative 24. Half of negative 24 is negative 12. So the y-intercept is 0, negative 12. So the x-intercept is easily solved for because this is already factored. Where we take each factor and set it equal to 0. Because again, by definition, let's make the output 0 this time. For the x-intercept, the output is 0. The y is 0. Remember that if the factors are negative 6 and positive 4, that the solutions are going to be positive 6 and negative 4. It's an opposite sign from what's in the parentheses. And then when we write the answer in intercept form, we write 6, 0 for the x-intercept, and we write negative 4, 0 for the y-intercept. How'd you do? Okay, the line of symmetry can be done finding the average of those roots that we just found in this last equation, the 6 and the negative 4. Imagine that you've got a parabola that touches at negative 4 and touches at 6. And I want to find the line of symmetry that's right in the middle of that. So by taking the average, we find the middle. So we're going to say that this line of symmetry, which is an x equals vertical line, is going to be negative 4 plus 6 over 2, or just 2 over 2. And so the equation of my line of symmetry is just x equals 1. Finally, for the vertex, we want to find this point right here at the bottom of this parabola. And I already know that the x value on that line of symmetry is 1, so I know that my vertex is 1 comma something. So couldn't I just go plug into the equation that I was originally given where x is a 1? So f of 1 equals 1/2 of 1 minus 6 times 1 plus 4. So 1 minus 6 is negative 5. 1 plus 4 is 5. Half of negative 25 is negative 12.5. So my vertex is at 1, negative 12.5. Okay, so that's how we get the y-intercept, the x-intercept, the line of symmetry, and the vertex from factored form. So the next section is having us convert between forms. So for example, in this first one, they're giving us a quadratic in vertex form. This is already in vertex form. And they're asking us to put it into standard and to put it into factored form. In this one coming up after that, they're giving us standard form, ax squared plus bx plus c, and they're asking us to put it in vertex form. That means we're going to use the method of completing the square. And the last one is the same thing, where they're giving us standard form, and they're asking us to complete the square to find vertex form. Now notice in this one, there is a coefficient greater than 1 that we're going to need to divide out. That -4, do you see it up there? Because when we complete the square, we want to complete the square on 1 square, not on -4 squares. Okay, let's go take a peek though at the first one. Going to standard form from vertex form means we want to go backwards and multiply things out. So the x minus 4 squared, couldn't I stretch that out like this? And now I'm just going to multiply those binomials. X times x is x squared. X times -4, -4 times x, -4 times -4. So that multiplied out to this big old thing, giving me x squared minus 8x plus 16, okay? Don't forget that there's a little 2 out front right here that's going to need to multiply. And way at the back, there's this -4 at the end. So here we go now multiplying or distributing the 2. So we get 2x squared minus 16x plus 32. And finally, 2x squared minus 16x. So now we just need to go 32 minus 4 would be 28. So this is the standard form. So this guy right here has this as the answer. Now they're asking us to convert that standard form into factored form. So the first thing I notice I can do is I've got that 2 out front. So I'm first going to, what color should I do? Let's do black. I'm going to factor out a 2 greatest common factor. So 2 divides out and leaves me x squared minus 8x plus 14. And then if I pause and look at this for a second, 14 is either 1 and 14 or 2 and 7. And none of those subtract to give me -8. So just taking out a 2, greatest common factor, is all I had to do here. There's no additional factoring I can do. It is done. Actually, let's use green for this one. No, let's use blue for factored form. Okay, moving on to the next one. Let's go do vertex form by completing the square. And we did one of these in class with the people who were in person. But remember, step 1, make space. We're going to bump the 3 over, making space right here to complete the square. Step 2 is the B work. My B in this one is a 10. So I go 10 divided by 2 is 5. 5 squared is 25. I have to add 25 to complete this square. But I can't just randomly add 25. I need to subtract 25 to balance. I just made the x plus 5 squared perfect squared factors, and then 3 minus 25 is -22. My vertex form of this parabola, is done. Don't forget this little squared up there. Okay, doing vertex form of the next one. This time, I've got that coefficient of -4 that's got to get out of there before I can complete the square. So I divide out a -4, I'm left with x squared. Divide out a -4, I'm left with -8x. And then we're just going to leave space and subtract 5 off the back. So now I can complete this square right here. Half of -8, here let's go do our b work. B over 2 squared is -8 over 2, which is -4 squared. So I'm going to be adding 16 and subtracting 16, but it's not just 16 one times, it's 16 -4 times. So my next row goes f of x equals -4. Let's get those perfect square factors. And then it's going to be -5 plus, what is 16 times 4? You got it, plus 64. And so off the back, we're going to have 64 minus 5, which comes out to 59. So what are the perfect square factors for x squared minus 8x plus 16? Good. You're right. X minus 4 squared. If you're not sure how I just got that, remember how we do the factoring where we say what times what equals 16 and adds up to a negative 8? And we'd say it's negative 4 and negative 4. So it's the x minus 4 squared factors. And so this right here, comes from this perfect square trinomial by factoring it. Okay, we're done. That was called converting between forms. How'd you do? Okay, down here at the bottom is solving all kinds of equations, no matter what kind. These first two that we're giving you are called exponential equations. The reason I know they're exponential equations is because the x is in the exponent. And so we're going to end up solving once we find the same base. Over here, we've got solving a quadratic. How do I know it's a quadratic? Because it's an x squared. We're going to solve that guy by factoring. Looking down here, I've got another, then we're on factoring. So anyways, let's go do these equations then. So 256 and 64 could both be rewritten with a big base of 4, meaning 4 to the power of something is 256, and 64 to the power of something is could be a base of 4. So 4 to the 4th makes 256, and then do you see this little 3 minus x that's already there? So I need to remember to put the 3 minus x in again. Let's stretch this out a little bit. Hang on. And then 64, 4 times 4 is 16 times 4. So 4 to the 3rd would normally be 64, but this is a fraction of 1 over 64. So it's technically a negative exponent. 4 to the negative 3 equals 1 over 64. And again, don't forget that little x plus 1 that's already there. So this guy comes from right here. Now that we have the same base, now we can set the exponents equal. Let's write that out. Hang on. So I'm going to take the 4, quantity 3 minus x, and set it equal to negative 3, quantity x plus 1. Now we're just going to distribute and solve. 4 times 3, 4 times negative x, negative 3 times x, negative 3 times 1. Adding 4x's to both sides, and then adding 3 to both sides. I'm getting that x equals 15. If I wanted to test this out, I could take this 15 and go back up here and write 3 minus 15. I could type into a calculator 256 to the power of negative 12, and then I could type into the calculator 1 over 64 to the power of, see how 15 plus 1 would be, to the power of 16, and those would both yield the same answer. So I would double check that my x equals 15 is correct. All right, the next one's an exponential equation as well. See that x in the exponents? So 36 can be rewritten as 6 squared. And then we note that there is already an x minus 2 there. Oh, sorry. Hey, there's a little minus 4 here. Let's get rid of that guy first. We want to isolate this first by moving the 4 over. So 36 can be rewritten as 6 squared. Don't forget about that x minus 2. And 216 could be rewritten as 6 to the third. Now that we have the same base, now I can set the exponents equal. And so we write 2 quantity x minus 2 equal to 3. We distribute to x minus 4 plus 4. We get 2x equals 7. And so x equals 3.5 or 7 halves, however you want to write it. How'd you do? Okay, on the next one, we're going to ask ourselves how to factor this to solve. What times what equals negative 21 and then subtracts to give me negative 4? So I'm thinking 7 and 3. Which one gets the sign? The negative 7 plus 3 is what works. So we get x minus 7 as my first factor, x plus 3 as my second factor, and now we're going to solve each piece. X minus 7 equals 0. And this is by the zero product property, that if something times something equals 0, then one of those somethings has to, or both of them. So we can set this equal to 0. So my two solutions to this quadratic are positive 7 and negative 3. And remember, when we solve quadratics, like, what is that? What am I getting when I get these solutions? And we recall that we've got this parabola that is touching at negative 3. That's the first 0, and touching at 1, 2, 3, 4, 5, 6, 7. So you've got this upwards oriented parabola touching at negative 3 and 7. When you find the solutions, you're finding where it touches on the x-axis. All right, next I've got just factoring. So the step above was solving. Factoring means we're going to stop at the parentheses for this quadratic. So what times what equals 36 and subtracts to negative 13? I'm like, okay, 1, 2 times what, 3 times what? Oh, 9 times 4. And then what signs should they get? And so my factors are x minus 4, x minus 9. If I want to test that out by multiplying to make sure it works, I could. Over here, this is greatest common factor, and I'm going to stretch this out. What times what equals 20x to the third? So I could say 5 times 4, or 5 times x. And then I say to myself, what is in common? And I see that there's a 5 in common and an x in common. So that's my greatest common factor out front. And then left behind is the 4x squared minus, since we used up this entire factor, we just hold that place with a 1, minus 1. If I want to double check if this is the correct factoring of this one up here, I would just multiply it out. I would do the opposite and see if it worked. So in my head, I can go 5x times 4x squared. That does give me 20x to the third. 5x times negative 1, it does give me negative 5x. Check, I got it. So this right here is called a greatest common factor, GCF. On the last one, I do see that there's a 2 that can be divided out of everything. There's my greatest common factor, leaving me x squared minus 4x minus 21. And then back here, I'm going to test it to see, can it keep going at all? What times what equals negative 24 and subtracts, negative 21 and subtracts to a negative 4. And I'm like, oh yeah, 7 and 3. It's going to be 3 minus 7. So my final factorization is x plus 3, x minus 7. Don't forget about that greatest common factor out front. And so these are your factors. regular factoring of a trinomial, greatest common factor, and then the combination of both greatest common factor and factoring the back trinomial. So being able to put the two together. How'd you do? That was page 2.